I know, I know. Okay, let me connect my board and then we are starting.
Yeah.
Now. Okay, so the first lesson is dealing with speed, and speed is distance over time. This is a very famous formula. Everyone knows it.
Yeah, yeah.
Okay. Speed is equal to distance over time. Now, speed can be measured in many units. The two popular ones are for the higher speeds, we use kilometer per hour.
Meter per second.
Okay. And when we want more
Hello,
precise
Mr.
calculation.
Bismillah.
Hmm. Finally, you are here, huh? Please
Yes,
open the
sir.
iftar, please. Please open the iftar now. Yes, have futur with me.
Oh yeah, open this page right here.
Okay, let's continue quickly. So, what I was telling that this chapter is dealing with speed, and speed can be measured in kilometers per hours as well as meter per second. I'm talking about the metric system. I'm not talking about the American imperial system that deals with miles per second and like yards per second. No.
Oh,
Currently, I'm
mashallah,
dealing with the
Mash.
metric system. Okay. What happened, Ibrahim?
Yeah,
What happened?
nothing happened.
Okay. So this is the basic formula. Speed is equal to distance over time. And we have to take care that the units are maintained. Okay, where is my pen? Okay, what do I mean by units are maintained? For example, if a guy traveled the distance of let's say 300 meters.
Mr.
And
Your screen is lag. Your screen is lagging.
my screen is lagging.
No, it's not.
Yeah, no, it's okay. Now it's okay.
Okay, okay. And the time taken, okay, time taken was like not 300, let's say 3000. Okay, 3000 meters distance travel by a cyclist. Okay,
3 kilometers.
Yes, and he took 5 minutes. Okay, now we want to find his speed. Okay, so speed is equal to distance over time.
We will convert the minutes to seconds.
What we will do?
Convert the minutes to second.
Yes, that's what we are going to do.
So
it will be 3000 over 5 minutes is equal to how many seconds?
300.
300. How? Because we are going to multiply it by 60.
Yeah,
because each minute, yes, each minute contains 60 seconds. So similarly, 5 minutes will have 300 seconds. 300.
Yes, Mr.
So 300 seconds here and here meter. Now, very easy to simplify this one. Very simple.
Yeah, no, very easy division.
10.
2 zeros and 2 zeros.
30. Very
so
easy.
3 and 30 means what?
30 meters
10
per
over
second.
1.
30 meter per second, Ibrahim, right?
Yeah.
La.
10 meter per second.
صح.
You did not simplify. You are just focusing on
Mr. Yeah, I got mixed up.
on the numerator. You ignored the denominator. Okay, that's why I'm saying.
yeah.
Pay attention. Okay, so speed here will be 10 meters per second. Now, what is constant speed or steady speed? When you are traveling on a car or in a car, okay, or you are on a bike and you have the speed that is not changing. Yani if you just lock it at like cruise mode, 100 kilometer per hour, something like that. You know cruise mode in the cars?
Yeah.
Cruise mode.
Oh, yes.
Well, Jamal, I'm saying cruise mode, not cheese mode. How did you start saying yes? I'm not saying cheese mode, cruise mode. Okay. So cruise mode is what? you shift your gears to cruise mode, and what happens? The car just maintains a constant speed on a highway.
Yeah.
And this is suitable on
Yes.
highways, not inside the city. Okay, you don't use
Yeah, I
cruise
know.
mode inside the city.
Yeah.
Okay, cruise mode on highways.
It's good for the like travel way, like travel.
Yeah,
route.
if you go for like a long time on the highway.
Yes, you don't have to put the race. You don't have to, yani, just keep on pressing the
Yeah. Yes.
pedal
Yes, yeah.
with your foot. Wow, amazing design.
Jamal's
Jamal's feet? No. It's this feet is very thin.
No,
No,
mister, my
mister,
feet are very big, mister.
it
That's
have-
why.
it
That's
have to
why
be
these are not
squared.
your.
It have to be squared.
It has to be squared. Okay,
Yeah.
average speed. Now, what is average speed?
Mister, the total distance and the total time.
Wow,
Yeah, total
wow.
distance over total time.
The student already know the concept.
Yeah.
Then
See.
then I can rush quickly. So average speed is what?
Total distance over total time.
Over total time.
Yes.
Divide them. Mister, you know that we can bring our calculator in the exam?
They allowed. They allowed this time?
Wallah?
Yeah, only for physics.
Yeah.
Yeah.
Oh, I need one then.
I will bring one.
You don't have?
Yeah, I don't have literally any calculator in my house right now. That's like functioning.
I have only one that
Now
is
you
on my
need to. Now you
Functional,
need to
functional.
purchase one. Okay. So what is the concept really? The concept of average speed is that, for example, in real life, we cannot maintain all the time constant speed because we have ishara, we have free road, we have traffic jam. So our speed of the car or vehicle changes with time. Maybe for 20 seconds, our speed is 100 km/h. And then suddenly we see the ishara, it's turning red. What do? We start applying brakes. Then
accelerating.
for the next 5 seconds, maybe our speed is like 90. Then for the next 3 seconds, our speed is like 80. So you see what? Within this time
It
frame,
changes.
within this time frame, our speed is decreasing. So what if someone asks, what is the average speed? What are we going to do? We are going to take total distance and then divide by total time. We are going to get average speed.
So it's
Okay.
distance divided by time.
Mister,
right?
can you give an
Total
example?
distance. Total distance.
Total distance.
Can you
Okay.
give an example, mister?
Okay, I'll give an example. Point A. This much means 100 meter. Okay, one block, one square. So I'm not going to write here. This is like 400 meters. Okay, is it clear, guys?
Okay.
One square.
Okay.
One square means 100 meter. This is the scale that we are going to use.
Okay.
Now, you guys have notebook and pen in front of you.
Yes.
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 Okay. And calculators also, or not?
Calculators.
No, without computer.
See, someone is so happy.
The kid with Mr. Too much.
Just by the name, someone is very, very happy. Okay, so there was a car. Okay,
Yeah.
which car? Which car?
Lamborghini.
Mitsubishi.
No, Lamborghini cannot be that
Rolls Royce.
slow. Give me a slow car.
Tamura.
Give me a slow car.
Mitsubishi.
Camry, Mister.
Mitsubishi.
Camry,
Mister.
Camry.
I'm offended by
Hilly,
your
Hilly.
comments.
Hilly.
Mitsubishi. Mister.
Isuzu, mister.
Hey, look.
Wait.
Mr. Batmobile.
Ah, don't offend me. Batmobile is very, very strong.
Cabris.
In Batman Arkham Knight, don't have you seen the modification
Yeah,
of car when you play that game? That's amazing game. Yes. So there is a car. Okay. Unfortunately, I have brought a speed supercar. Okay. It's not your normal everyday car, average car. Okay. Now, this car for the first 20 seconds, it traveled this much distance, and then for the next 15 seconds, it traveled this much distance, and for the next 40 seconds, it traveled this much distance. Is it possible? Yes, it is possible, because maybe the ishara was here.
Yeah.
And maybe like you have a market somewhere. Now, if someone has to calculate the average speed of this journey, what are you going to do? Total distance over total time, correct?
Yes.
Yes.
Now, what is the total distance?
1,200 meters.
How do you know?
I counted them.
Let's count the squares. 1, 2, 3, 4, and then
5, 6,
5, 6,
12, 1,200.
7, 8, 9, 10,
7, 8,
11.
9,
11,
10, 11, 12. So 1,200.
200.
Over 75 seconds.
Yes, sir.
Yes.
1,200 seconds
75.
divided.
No, Mr.
Oh, meter.
No,
Sorry,
no,
sorry,
no,
meter.
meter.
Yes. Harder. Yes, Saz. And then over time. What is the total time taken by the car?
75.
75 seconds.
75 seconds.
75 seconds. Simple. So now you can use your calculator and tell me the answer.
حتى no need calculator for this one. This is easy math.
Yeah.
Tell me.
16?
Yeah, 16.
Yes,
Oh my
16.
god, غشاش.
I don't Google it. I have calculator in my brain.
Me too. No, I have in my phone.
Good one. Okay, so 16 meter per second will be the answer. Mohammad Abi, did you get the idea? What is actually
Yes.
average speed? Okay.
Okay.
Not
Okay.
speed, average speed.
Now, yes, average speed. Yes. See, these pages are still loading, huh? Okay, so we have to run quickly. We have a very less. Okay, Alhamdulillah, we are not studying the earthquakes here. Okay, so don't worry. We are not studying the tectonic plates.
Tectonic plate.
So speed can be increased of a car. How? If there is a wind going on. Okay, in storms, sometimes they were stuck for days with very little wind. Their speed varied depending on the wind. These points are related to what? Related to, I think, the boats. There is a story given here. I'm not dealing with this story. Indian story, definitely. Okay, I'm not going to deal with that. You can read it. Now, instantaneous speed is what?
Mister, the speed is the speed in the same moment.
In
Like
the same
no
moment,
time.
instantly, like a very short period of time.
على طول.
Okay. Yes, ala tol. For a very small period of time, that speed is worked out from the size of the wheel. So on the car, it is not the average speed. Okay. So, like for example, they have given when you are traveling. So on your speedometer in your car, you see that, okay, now the speed is here. When you put the race, it reaches somewhere here. When you put more race, it comes here. And then, for example, this is 120 km per hour mark. After 120 km per hour, it says teen, 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 teen. Okay.
Yes.
So instantly the speed is changing. If you are increasing, it will become 120, 130. Yani this speedometer is giving you what? Average speed or current speed?
Current speed.
Current speed.
Current speed, which is known as instantaneous speed. Okay. This reading is not. This speedometer is not giving you the total average speed. No, he's giving you the instant speed. If now the speed is 40, if it will give you 40 instantly. If you increase it to 60, it will give you 60. Okay. So this concept is known as instantaneous speed. Surah. Now Jamal went 2 kilometers away from the microphone.
How did
He's-
you know,
he's-
mister? I went to take my mouse, mister. It's far.
Because your voice was so light.
Mister, why are we
Okay.
the presenters?
These are some of the examples of our day-to-day life. Okay. For example, if we are walking quickly, our speed is somewhere around 1.7 meter per second, or if you want to convert it to kilometer per hour, it will be 6.1. I will tell you how do we convert. Okay. Just multiply it by 3.6.
3,600.
3.6
Yes,
in your calculator. Just do this.
Mr. What,
1.7 multiplied by 3.6. Yes, this is the answer for everything. Okay.
what I do,
3.6.
Mr. Like multiply the number by 3,600 and divide it by 1,000. And I will get the
So
answer.
basically it is 3.6.
Yeah,
أيوة يعني.
3,600 over 1,000 is what? 3.6.
3.6
So that's the
multiplied by
factor.
Yeah.
Okay. So I will write it down to convert meter per second. I will write it here. To
Wait one
convert,
second, I'm gonna be
you can
right
note it
back.
down. Okay. To convert meter per second to kilometer per hour, please note it down in your notebooks. You multiply by 3.6. And when you have to do the opposite, kilometer per hour into meter per second, you do a division.
Mr. This was as a homework, like to convert this table to kilometers, like to prove how to make it.
And you can check it now in your calculator. Do this one. 255 multiply by 3.6 and tell me what are you getting exactly.
Okay. Uh, 918.
918. Okay. See.
Yeah, no.
Okay. Now, precision and accuracy. What's the difference? Okay. I remember a few days back in my college, like maybe 3 weeks or 4 weeks ago, like 1 month ago, my teacher asked me the same question to us students because we were studying some chapter about research. Okay. So she asked me, what is the difference between precision and accuracy? Who can tell? And I'll tell you the same example she told me. I'll tell you the same example. Okay, let me bring something.
Mister, I have a picture, like also the Mister in our class showed it to us. I can send it on the group.
Send me.
I sent it, Mister.
Ah, yes, I was going to bring this. Okay. Meaning to say what? I'll give you a real life example. If there is a boy who wants to talk a lot, okay, everyone will remain silent, huh? No one will give names. Okay. Now, if there is a boy,
Okay.
okay, if there is a boy who wants to talk a lot, irrespective of is it true or false, he just keep on talking. He wants to give reply to people. Okay. Now you ask him, what is the distance between your school and your house? He will just give a number. The distance between my school and house is 8.231 kilometers. Okay. He give you this answer, this exact answer. Okay. But in reality,
That's for scientific figure, Mister.
even for significant figures, they are not scientific figures, significant figures. Okay. Now the reality is between his house and school, the distance is only 2 kilometers. What does it mean? His answer was very, very precise, but it was not accurate. And it was so precise that he used 3 digits of decimal to give his answer. Yes, but was it correct?
No.
No. So your thing has to be accurate as well as precise. Okay. So what was the accurate answer? What was the correct answer? 2. But what he was saying 8.231, or he could have said 10.253.
Hello,
Okay,
Mr. Abad.
but does that make it okay? So but does that make it correct? No. Okay, so that's the difference between precision and accuracy, and this dart example is very good, that you are hitting at the center, so your accuracy and you are accurate as well as precise. Now here
الساعة 8.
Huh?
Well,
للعربية اضغط واحد ها please please हिंदी के लिए 3 दबाएं. Okay, so in this example, in this one example, all the shots are so near to each other, but are they hitting the target? They are so far away from target. Okay, so they are precise, but they are not accurate. Okay, and the last one, it's neither accurate nor precise. Okay,
Mister, what means accurate?
accurate means correct to the nearest answer. Correct to your answer.
The nearest answer?
No, nearest to the correct answer. Accuracy means what? I'll tell you. Accuracy.
like Mr. Accuracy for the answer and precise for the tries.
Accuracy means close, as close to
The real answer.
the answer as possible. Okay, this is accuracy, as close to the answer as possible. But what is precision?
As close to the tries as possible. Or to
No,
the,
precision means very small values. They can be correct, they can be wrong, but they are like very small and fine values. Means
Yeah.
what? 1.238 centimeter. Okay, whether is it correct or not, it's none of our concern, but it is very precise, yani precise calculations. Like when the race begins and it ends, the sprinter, the racer takes like 8.23 seconds to finish the race.
Yeah.
So if I tell you he take 8 seconds.
Wow, سريع.
And if I tell you he take 8.23 seconds, which one is precise?
8.23.
8.23, okay? So the meaning is it's very small and fine reading. Not Kleenex, huh? This is fine reading.
like Mr. It gives more information.
More information, yes, you can say it's giving more information or having multiple decimal places. So where is accuracy important and precision important? In race. One of the example is race. Yani in the race, the guys are so near each other. If you just do not use decimal, then you cannot define their time. Yani if you say the first prize winner is 9 seconds, and the second prize winner is 9 seconds, and the third prize winner is also 9 seconds.
Yeah.
People will hit you if you will give this type of news. Okay. So you have to give some precision. Okay, the first guy was 9.12 seconds. The second guy was like 9.25, and the third was 9.83. Now you are giving a precise data. Okay.
Yes.
Does it make sense?
Yeah,
Yeah.
Mister, now you can know the winner in the race.
Now we can know the winner. Yes. Okay.
Yes.
Now let's quickly. I will not go into too much of theory. They are giving some story about Olympics. You guys know Olympics? What is
يحسن
Olympics?
بولت
Yeah.
مستر.
Yeah.
You have seen, huh? Hussein Bolt. Yes, Hussein Bolt.
Yes, مستر.
Balut.
The Arabic version, مستر.
Then, okay. Why Bolt? Make him Batta. Make him Batta. Bolt. Hussein Batta. Hussein Batta. Okay. So there is a story. You can read it. Okay. And they have given some time that. Okay. Now what happens? 2 runners got the same time, 9.8 and 9.8. Now how we will decide the winner? We need
By the-
one more decimal place.
Yeah,
Yeah.
precision.
The
If
third significant.
if the stopwatch gave us something like 9.83 and 9.87, then we can decide a winner.
Yeah.
But if we do not take that precise watch, if we take a cheap watch, it is giving us 9.8, 9.8. It will be a trouble to
Yeah.
decide the winner. Yes.
Yes.
So that's why precision comes into importance.
Mister, there is something I didn't understand in this lesson.
Is
About
it
the
on
light.
this page?
Yes, no, the second page.
I am on the second page itself. Oh, I am on the third page. Okay,
no,
once
not
I finish.
He
second
means just
page,
the second page in this lesson.
second
Once
page
I-
from this lesson.
Second page of this lesson, yani you mean the next page here? Huh?
Yeah.
Yeah.
I'll explain, but I didn't even go there. So now what is reaction time? Okay. Reaction time, for example, for keeping the time, there is a human. Yes. Till now, there is no robot to start the time, right?
Yeah.
There is someone who will fire the gun.
Yeah.
And then the race will start.
Boom, boom, boom.
Yes.
But
Okay.
Mr.
So
Mr.
there
it's,
is a delay between he clicks the button and the actual race
the brain
starts.
information.
Yes. Yani the brain takes the information and he clicks the button. So this delay is known as reaction time. For example,
By the internet.
Riyadh already knows this lesson. He knows all
Yeah.
the values.
Mr. A just has a lot of ping, mister.
At 0.2.
I should play FIFA with him. His ping is good, so he cannot make an excuse today.
Yeah.
Because when I beat the kids, they give me lame excuses. I don't have the ping. My controller is broken and fulan and kaza whatnot.
The cat pressed on the controller.
Please. Okay. So what is reaction time? Let's read the definition or the example they have given here. Okay. When automatic timing was first introduced, the measured times for the 100-meter got longer. When a stopwatch was used, there was a short delay between what? Between the judge hearing the gun and actually starting the stopwatch, because the judge hears the gun and then he starts the stopwatch. Now, as soon as the gun starts, the runners will start running.
No.
Yes.
Yes.
No.
And
No,
0.2 seconds, mister.
they has a delay, Mr. The judge.
who? The runner or the judge?
No, the runner has a delay. 0.2 second.
But judge also.
Yeah.
Judge also. Yani when the judge hears the gun, he clicks the stopwatch in approximately 0.2 seconds. Now, what about the runners? Let's read it here. It is the time that takes the brain to process information. It is typically about 0.2 seconds.
Yeah,
Okay.
mister, very simple lesson.
Very simple lesson. The judge stood by the finish line. They could anticipate when the athletes would cross the line. This meant that there was not the same reaction time when they stopped the stopwatch. The times measured were shorter than they should be by 0.2 seconds. Automatic timing is more accurate. Definitely, because in automatic timing, the reaction time will not be there because a human is not involved. Machines and sensors are involved,
Sensor.
right?
Yeah. Yes, Mr.
Okay. So what happened? Now there is a system here.
Yes, this is the thing I didn't.
Yeah,
I'll
mister,
explain.
This is the one that I didn't understand, mister.
How?
Now there are two sensors. Sensor number 1 and this is sensor number 2. Okay.
Okay.
Sensor number 1 starts when the ball passes through it.
And sensor number 2 stops.
Stop.
when the ball
Yes,
passes
yes,
through.
yes, yes. I'm coming. Yes, yes, yes. Now listen silently. So, and the ball is coming here. And once it passes through this second light gate, the time is
Time
recorded
also.
for the interval, okay? How much time it took. So this is far more precise and accurate than the human time calculation by the judge or by someone else, timekeeper.
Because
whatever,
there's no
okay?
reaction time.
And there is no reaction time. It's automatically starting here and automatically ending here. Okay. So let's read some details as they are mentioned here. It is important to think about reaction time if you are timing an experiment. If you are timing something over a long period of time, then your reaction time will not make much difference. Definitely.
Yeah.
And if we are taking a 2-hour race like a marathon or a 3-hour journey or 5-hour journey, 0.02 second is not a big deal, or 0.2 second, it's not a big deal for us. But it is a big deal in 100-meter races, in 200-meter races, in small span of time. Okay, so if you are timing something that happens very quickly, okay, then reaction time will have a big effect. Okay, now Dave is a name of a boy, is doing an experiment about air resistance. He drops a ball from a meter off the ground. He times how long it takes to hit the ground. The reading on his stopwatch is 0.65. Because this time he was involved, he got a delay. Why? Because he's a human. He took some reaction time. So he got how much time? 0.65. But 0.65 contains an error, an extra additional time of 0.2 reaction time. So if you subtract this,
it will be
what are you going to get? 5 here and 0.45.
Yeah.
Adnan and Badr, are you there?
Mister, I didn't understand this part.
Yes.
Like the part of the lighting gates.
Yes, Mister.
This is okay. And others are there? Adam is there?
Yes.
Yes,
I'm
yes.
here, mister.
Okay. See, the light rays are coming here. And there is a sensor that is catching the light here. There is a sensor here.
Okay.
Okay. Now he is catching the light and he is absorbing the light continuously. Now when the ball comes in here, there will be some obstruction. So the sensor will know that something passed. How it will know? Because it's blocking the light.
Because it feels it.
Oh yes.
Okay, so at this moment the light can only go from top and from bottom, but from this middle portion the light is being blocked. Yes, Amir?
Yes.
At this time the sensor will start its timer and it will stay open until it hits the second light. So it knows, there is this object that entered and then exited. So the difference in time is 0.4. Okay.
Okay.
Be right back, mister.
Okay.
And in this Dave example, this is something else. Okay. This thing is something else and this thing is something else. Do not get confused that these two are same things. Okay. These two things are different.
Okay.
This one, a man is involved. In this one, a machine is involved here.
Machine.
A sensor.
Okay. So let's, and you guys understand what did I do here?
Yes.
Yeah.
Yes.
Let me bring water. Very thirsty. I'll be back in a minute, inshallah. You guys can also bring water. Wow, chai.
Mister,
Yes,
I have
Adnan.
Jake Carmen here right
Bring
next to
a
me,
cup of
mister.
water.
Water.
Water. Mister. Water.
Hydrated enough. Okay, मैं वापस आ गया. I mean, I'm back.
كيف حالك؟
Mister, you
كيف
bring a
حالك
water.
مستر؟
الحمد لله أنا بخير.
Mister,
وأنتم؟
you bring a water.
I bring a voucher. I bring pani. Pani is like water in Urdu. Pani. It means water.
Makkah موية Mister.
Not Makkah. It's the groundwater.
No,
After.
no, there's a water. It's called Mecca. It's from Safa.
ماي زمزم ماي زمزم.
No,
What is Makkah water? Coming from the Makkah Mukarrama?
no,
What?
no. There's another one. There's a water called Mecca. Not the.
The Sharika Makkah.
Yeah. Yes.
Okay. So light gates is clear. And what is the special thing about light gates? That they are so precise that they can
Sensor.
record even 3 significant figures. 3 significant figure means what? For example, 9 point, you are the Google Translate today or what? 9.23 seconds. So first significant figure, second significant figure, and third significant figure. Okay, it's so precise. Okay. Explain, all the answers are already done here. Explain which measurement from the list below is most precise. The one that contains more digits.
The one that contains
after
more
decimal?
than كم من
More
number.
numbers.
Yes, Jamal was giving some explanation. Yes, yes, Mr. Jamal. Yes, you were saying something. How we
خلاص
will
إبراهيم
decide?
سيت مستر.
No,
You say it
no,
first
no,
قلبي. You say
no.
it first قلبي.
لا خلاص
First.
إبراهيم سيت مستر.
لا خلاص.
Okay, what did he say? What did he say? Repeat. شبكة خربانة. شبكة بطيء. Okay. So how you guys can tell which one is more precise after the decimal? Who has more digits? It has 1 digit. It has 3 digits. It has 2 digits. Okay. So definitely this one has more digits. So this is more precise. Okay. Explain why timing gates give you more accurate measurement.
Because it's mechanical. It make more sense.
Because in time gates there is no a delay.
Yeah, there is no delay, there is no reaction time because no human is involved. The machines are involved. Okay, like Jamal said, the sensor get triggered and they start the time, and when the ball passes through the second time, the time stops and the difference in time is recorded. Okay, now explain why automatic timing is more important in 100 meter as compared to marathon 42 kilometer. Yes, tell me.
Can I say Mr.?
No, new this time. This time Badr will give the answer. Amir and Riyad have given so many answers, and even Jamal and Ibrahim. No, Ibrahim has
I
now
don't give
let me
answer.
ask Adnan, Badr, and Adam. These 3 students need to answer now few things. Now, Badr, tell me why automatic timing is good for 100 meter and not for 42. Why it is better? Yes, tell me why automatic timing is suitable for 100 meter race and not for 42 kilometer marathon race. Why? Brother. What happened? Adnan, why is Badr not replying?
Maybe
I don't know.
He's
not with me in the room.
Yeah, we know you are rich.
Okay.
Let's go to his room.
Oh, Riyad, please, no comments required. Yes, Adnan, give the answer. Why automatic timing is suitable for 100 meter race?
Mister, I can say.
Adnan, do you know the answer?
No.
Adam?
Yes, mister.
Yes. What about you? You know the answer? Wait,
Because
Mimi.
mister, because the automatic timing is more accurate.
No, but both are races. 100-meter is also a race. Marathon is also a race. In which race we are? It is better to use automatic timing. In what type of races? Adam.
I don't know, mister.
Okay, Amir.
Yes, Mister. Because in a 100-meter race there is less time, so the delay time will affect on the race. But the 42-kilometer marathon is have a long time. Yeah.
It has long time. People run for 3 hours, 4 hours, 4.5 hours.
They have more
and
distance
then they
between
finish.
them. They have more
So
distance between them.
for example, you finish the race, okay? Your scorecard will look something like this: 4, 10, and like this. It will look like this, meaning to say what? How much time did you run? Tell me. How will you read this number?
4
hours
and
and
10
3 seconds.
4 hours and 10 minutes and
Very good. 4
and
hours,
3 seconds.
10 minutes, and 3 seconds. So microsecond is not required. We don't want 3.47 here. Yes, it's not. It's irrelevant. Okay, Adnan and Badr and Adam. Now it's better.
Okay.
Yeah, mister.
Okay. So the last one, when sprinters start a race. Sprinters are what? The one who are running. Okay, the athletes who are running. They are known as sprinters.
ايش اسمه؟
اسمه Khalid. When sprinters start a race.
أحمد فارس.
When sprinters start a race, sensor in their starting blocks detect a change in pressure. If the time difference between the starting gun going off and the change in pressure is too short, a false start is registered.
This is story, Mister, not a question.
Which of these times could be the time difference that gives a false start? Less than 0.2, 0.2, more than 0.2 second? Explain your answer. Let me read it one more time in my head because it's a big story. So sprinters start a race.
Exam will finish and I didn't finish the reading it.
Yeah. If the time difference between the starting gun going off and the change in pressure is too short. Okay. What is this? Can you guys imagine? What horrible thing is this? He is just about to start the race and his both feet are resting here. One feet on this triangle, 1 feet on this triangle. Let me bring an image.
He's doing push-up, Mister, not.
He's doing push-up, Mister. He's saying 1, 2, 3, 4, 5.
Wait.
Now 5:30.
No, I'm bringing.
There's a photo, Mister. The same thing, in the same page. You can see.
Mister, he's sleeping.
He's.
Mister, there's the same picture in the same page.
Same page?
Yeah, see up and the right.
Yes. Okay.
Yes,
so,
yes.
Oh, look at the physical health of this guy. So amazing.
He's
Okay.
very معضل.
Yes. Now, what is the Google Translate for that? He has so many bones.
No,
It's
no, no, no.
muscular.
Muscles.
Muscular.
Muscles.
معضل.
But I think the Azam is the bone.
Yeah.
Yes, yes, yes.
Muazzam,
صح, صح.
how is Muazzam not bone?
Muscle.
Wow, you changed the meaning.
Yes, mister.
Okay.
The accent. It depends on the accent, mister.
Accent wala Corolla. Okay, we have some blocks here, the sensors, okay? So when he pushes these starting blocks, the time gets started.
Yes.
Yes?
Yeah.
Or no?
I think yes.
See, it
Mister,
is
I
written
said
here.
yes.
Yes. Starting blocks are connected to the timer. So it also helps. It also helps us know that when did the racer or the sprinter start his race.
Mister, I will know when he started running, mister.
Yes. Please don't become a judge. Race
Okay.
judge. Let me erase this guy. This is like about to fall. Already falling on the ground. So there is a scenario here. I will read this one and then I will give you a later comment. I need some time, okay, to understand this and then give to you the explanation. So if after the class I do this one, I will give you the explanation. Now we need to finish these 2 pages, then I will take a small break, then we will finish the remaining things. Now we have graph, okay. Graph in mathematics we have already done many times.
Yeah,
now let
last
me
term.
ask you, last term, yes. Now this is a graph that is dealing with distance and time. Now please tell me at the 5th second, what was the distance traveled?
32. 30 or
30.
I think 30. Mister.
Okay. And
30
what
for
about,
distance, and the time is 5.
yes, that's my question. And what about 10th second?
10 is 60.
60. It's like the math.
Yeah,
Yeah.
mathematically.
Okay. So this graph was made using these values.
Yeah.
And this is very simple how these values are formed. 2, 12, like this, 2, 12.
Yeah.
And 4, 24. I already told you, yes.
Yeah.
4 you will look here, 24 you will look here, and then you will make some points like this.
Yeah.
And then 2, and then 2, 4, and then you will make on 6, you will make on 8, you will make on 10. And then what you are going to use? You are going to use a ruler and connect all of them. It will form a straight line. If it is constant speed, yani if it has a constant speed, the graph will be a straight line. If it is constant speed. But if it is not a constant speed, no, it will not be a straight line. It will be curved. It will be curved.
Mister, here
Something like this.
They will be asking about
حلو.
they will be asking about the slope, Mister. I will do the slope from a graph.
The slope is the same the speed.
And slope is the other name of gradient.
Yeah.
Okay. Slope is the other name of gradient, and gradient we have done multiple times previously. Yes. How do we find gradient?
I forget.
Me too.
Okay, I'll give you an example.
Mister, it's like the speed distance over time.
No, he's talking
Yes,
about.
I'll tell you what. Now, in this graph, time is passing.
Zero speed. This in this graph is
Yeah, zero speed because there is
Yeah.
no distance. It's like steady speed.
no. it's
So
not
the
steady
distance
speed.
is same. No, the distance is same.
Yeah.
But the time is going. And the guy is stopped somewhere.
Stop.
That's
at
why.
rest, at rest.
Yeah,
That's at rest. Yes, the object is at rest. Okay, the object is stationary. And let's compare two graphs side by side. Okay.
okay.
Now, in this graph,
Okay.
you have a line going here. And in the second graph, you have the line going here. Now, if you are here with a cycle,
I will
Okay.
go down, not up, mister.
yes, if you have a cycle here, okay, and you are going down, and you have the same cycle
Going up.
There is easier.
or going
but
up.
The over there is harder. I go down.
Mr.
So which one
Vector,
is more xiao down? Which one is more dangerous? A or B?
A.
A is more dangerous because see, it is so steep. You will go like this in an instant. Okay, but B is also dangerous, but not as dangerous as A. Now, if A is like this, it means it is more steeper in English. Okay. Yes, Adnan.
Or Mister, the slope is higher.
It's more
The
steep.
slope is higher, Mister.
صح.
Mister,
What, Riyad?
it's the same. Like the slope in A is higher than B.
Yes, definitely. The slope of A is more than the slope of B. It means what? A has more speed. Yani more steep means more speed. Less steep means.
Less speed.
Wait. Let me check. Am I saying correctly? Let me check it. If you have something here and if you have
Meow.
something here with the same time, this thing is taking a lot of distance. This thing is like taking less. Yes, I'm correct.
Yeah.
I'm correct.
but Mister, there's two types of graphs in this two lessons: the distance time graphs and the speed time graphs.
Speed time graph will have the acceleration and distance time graph will have the speed.
Yes.
So steep is equal to fast, and shallow or less steep is what? Is equal to slower speed. Okay. Now,
Mister, the Mister in our class, like he
We have a
explained
story,
this,
Mister.
he explained
We
the
have a story.
slope by a way, like Mister, you can return to the
I will
first.
tell you. I will tell you.
Okay.
Who is taking the
Mister,
optional class?
what is zigzag?
I make you the presenter now.
Me? Yay!
No, because Mister, I told you, I'm telling you how the Mister in our class explained.
Okay, now let me handle.
No, the mister in our class don't explain.
ترقيع Mister, ما شاء الله.
I think
ما
today
حد
there
ما
is
حد شاف يا مستر، ما حد شاف.
Okay. So there is a student, and this is the journey traveled by him. Okay, not her.
Mister,
him.
he's climbing a mountain, mister.
No. This is not the height. Don't think that this is a mountain. I'm telling you the graph.
School, Mister.
Yeah, mister,
It's
he's
a
just
general
messing
school.
around with you.
It's a general school, Mister.
Now, there was the beginning time here, 0. And in this phase, in the A phase, or in the A duration, what happened? How much time passed from here to here? How
10
many minutes?
10 minutes.
10 minutes. And how much distance was covered?
1000.
1000 what? Shawarma?
meter.
Ahmed Fuad finishes it in 1 second, mister.
meter.
Jamal, what about you, Jamal? You finished in 0.2 seconds.
Mister, I can
You are
barely
faster
finish
than
one
him.
shawarma.
You are faster than him.
Yeah, mister, he's getting a big kirsha now.
You can't finish a shawarma because you already have 2 burgers in your mouth. Big burgers. How do you finish shawarma? That's the reason. Please do not bring the name of the student that are not present here. Okay. That's not fine. Okay. So within the first 10 minutes, that student traveled 1000 meters. What happened, Jamal? Now tell me, you are talking a lot now. Tell me between these 2 blue lines.
He take a break.
You take a break. How do you know that? It is like a Sue moment now. How do you know that?
Because he's تعبان, mister.
Mister, the respiratory system.
Yes, he took a break. Okay. For how many minutes, Jamal? He took a break.
1 hour at least.
What?
Not you. I'm not talking about you. I'm talking about that student.
20 minutes, 5 minutes.
Yeah, 5 minutes.
No, jokes aside, quickly. We have so many lessons, Jamal. If you know the answer, answer it quickly. Otherwise, I need to pass the answer because it's taking a lot of time.
Like 12.5, something like that.
Wow, you are just taking the midpoint. That student started the break at 10th minute and he finished his break at the 15th minute. So how many minutes actually?
Five.
So you have to subtract this from this.
I
mean, you have to subtract 10 from 15. You will get 5 minutes. Clear? Now, what did he do after 5 minutes? He again started his journey. And this is the duration now. Now, in this duration, how much time was done and how much distance was done?
15 minutes and
15 minutes
and 400.
Not 15.
He started at 15. He started at 15 minutes.
Started at 15 and somewhere in the middle.
Yeah. 22.5. 22.5.
No.
Oh, 22.5. 27.5.
27, yeah.
27.5. Badar, not just 27, 27.5. How? Because it is the middle of 25 and 30. Okay. So from 15 seconds, he traveled all the way to 27.5 seconds. So
12.5.
how many minutes? How many minutes?
12.5. 12.5.
خلاص ذبحت المستر.
And he like the distance was
12.5 minutes he traveled. And what was the distance traveled? He traveled from 1000 all the way to somewhere around like
2,400.
2,400.
So what is the total distance here?
1,400.
1,400.
1,400. Jamal, explain how 1,400. Explain.
Mister, I was gonna say how 1,400.
No, but I already said it before you. Now you are stuck. Reverse Uno. Yes. Now explain the answer.
Cause he go from 0 to la.
It was yes. Now la.
Yeah,
because from 1,000 he resumed his journey. I'm not
he took 1,400 minutes.
Huh?
He took 1,400 minutes.
Distance.
Jamal, please take a rest now. You need to take a 10 minutes break now here.
Okay.
You need to take a 10 minutes break now. I'll quickly finish this graph. So what happened in the next 12.5 minutes, this boy traveled from 1,000 all the way to 2,400, meaning to say what? 1,400 meters journey.
Over 12.5.
Then again he took a break.
Wow, he took خلاص.
Then again he took a break for how many minutes?
1 hour.
7.5 minutes.
Jamal, you will be muted, huh? Okay. No. Should I mute you?
No, Mister. No.
Yes, for how many minutes? Adnan, how many minutes did he take a break?
Mr. I can answer.
No, I said Adnan. I'm waiting for Adnan.
If he didn't reply me.
Yes, mister.
Yes, tell me in the D duration.
Yeah.
Okay, in this duration D, how many minutes of break did he take?
Okay. Tell you only the answer or the steps?
Tell me the steps and answer.
Okay.
Easy peasy.
You will make 35 minus 27.5
Correct.
equals 7.5.
Yes, very good. 7.5 what? Tell me the unit also.
Minute.
Minute. So this time he took a break of 7.5 minutes, and then he took the final part of his journey, which was how many meters? Badr this time. Badr this time. In the E duration, what was the distance traveled in the E duration only?
E?
Yes, in the E duration only.
Yes.
Tell me.
Steps.
What is the distance traveled?
3,500.
3,500. How can you tell me?
What was that?
Now, are you doing this that in front of E, we have this, so this is the answer. Are you doing this? No, we don't do like that. I'll give you a hint. From this time all the way to this time, how much is the distance between this? Badr, tell me, how much is the distance between these two black lines?
2,500.
How? What is the top distance? Tell me, what is the top distance? 4,500. What is the bottom distance?
2,500.
No, it is slightly less.
2,400.
2,400. Okay, so 2,400. Subtract these two numbers, Badr, and tell me what are you going to get?
2,400.
2,400. Really?
2,400.
2,100. Yes. Okay, so this is the distance in meters that he traveled in the last part of his journey. I hope this graph was clear to everyone. If not, tell me, I will clarify by the letters.
Mister, can we get, we make a slope by this graph?
Yes, but at different locations.
Yeah, like
before that, during the last part of his journey, E part, okay, how many minutes did he take to cover the
10,
E part?
10.
10. Riyadh, very good. Explain. How did you get the answer 10?
Because Mr. he starts from 35 and he finished to 45.
Yes, because he started at 35 and ended at 45. So how are you going to do 45 minus 35, which is 10 minutes? Now, Amir asked a question that, Mr. Can we find a slope? Yes, we can, but at different locations. Like if I ask you what is the slope of E, what are you going to do? Make a right angle here.
Oh, yes.
Okay, and this is delta y. Delta y means what? The change in y. And this is what? Delta x. Okay, now.
But Mister, why is it called delta?
This is a Greek symbol.
Ah, okay.
Delta is used for difference in. Okay, difference in. So difference in x over difference in y.
2,100 over 10.
So it will be what? 2,000. This is 2,100. Yes, we just now solve it. And this one is 10 minutes. So what will be the average speed here? Average speed for the E location, okay, will be 2,100 meters over 10 minutes is what? 600 seconds.
600 seconds.
So what are you going to get here in calculator? 3.5.
30 over 2. Yeah, or 15 over 1. or 3.5
meter per second. Okay, this is the speed during the last part. What about the A part? What is the speed in the A part? Same procedure, same procedure. How much is the delta X here? Delta Y here?
10.
1000.
Not 10, 1000 meters.
Yeah, 1000.
Or delta
Okay,
Y.
what is the delta Y? Delta X?
X
10.
10.
10 minutes.
Yeah.
So what will be the speed? 10 minutes is what? 600 seconds.
600,
So
yeah.
average speed for the A duration will be what? It will be
100
1000 over 600.
Oh yes.
What 100? What 100?
I don't know. I forget
Will
to.
be
1.7. 7.
Yeah,
1.6.
1.6.
1.6666666.
Yes. But if we will
Meter-
convert it to the
Meter
nearest
per
one,
second.
Yeah, but listen, the last thing it's 7. So it will be.
yeah, if we will
No,
convert
they are rounding off. They are rounding off. They are rounding off. It will be 1.66666 forever, which they have rounded off. They have set 1.7.
6.
Okay. Now we will take a small break of like 10 minutes and we'll be back, inshallah. Okay. Assalamu alaikum.
Inshallah.
Okay.
Assalam.
Okay, last 2 minutes. Let's come back. Last minute. Okay. Yes, come back. Is everyone there?
Yes, me better.
يا أمير يلا.
And
Amir? Riyadh?
يا مستر هير.
Jamal?
Yes, mister.
Badar?
yes, mister.
Adnan?
Yes, mister.
Ibrahim? Adam? Adam, Ibrahim and Amir. Missing.
I'm here.
Mr. Adam came back, mister.
Send it in the WhatsApp, mister.
Okay. Amir came? No. Amir and Ibrahim.
Yes.
Maybe after time they will come back, mister.
Maybe after like 5 minutes.
So at this page, I told you that if it is a straight line, what does it mean? If it is a straight line, what does it mean?
Steep faster.
No. If the graph is a straight line, what does it mean to you?
Steady speed.
Death.
Steady speed or constant speed. This is the answer I was looking for. This means steady or constant speed. Means the speed is neither increasing or not decreasing. It's stuck.
It's the same.
Same.
At a constant. Simsim Kamoon. Yes. So in the case where the speed is not constant, like in real life, okay, so the line will be changed to curve. Okay, the line gets steeper, the speed of the ball is increasing, it is accelerating. Now in the case of acceleration, the curve is going upwards. Okay, and in deceleration, the curve goes down and down, and finally it goes to 0. Like the wheels on the bus go round and round.
Round and round.
Or down and down. Round and round. Jamal is listening to nursery rhymes or what?
Mister, my brother watches too much YouTube, mister.
No, Mr. They're very good songs. MashaAllah.
Mister, he watches too much Cocomelon, mister.
Too much Pokemon?
Cocomelon, mister.
Okay, so Jamal, can you explain what is acceleration?
Acceleration, like the two meanings or the...
Two meanings? What? Give me just one meaning, I'll be happy.
Acceleration is like a constant speed or a steady speed, right?
No.
Mister, I can answer.
Yes, Riyad.
Moving faster.
It is
Moving faster is better. Or
Mister,
yes.
it's a final speed subtract with the starting speed.
Divide by time.
Yeah, divide by time.
But you are telling the formula. Tell me the concept, something. I will tell you. What is acceleration? With the passage of time, you are increasing in speed. Meaning what? You started your car. The car was at rest. Let me bring the same car. The car was nice.
Yeah, it's Lamborghini.
Lamborghini.
Yes.
What is happening to my screen? Okay, where is that car? The car is here, tiny. Okay, let me copy it and paste it here. Okay. So with the passage of time, for example, the car was here and it started to move after 5 seconds. No, say 3 seconds. The car came here.
Mister, like the acceleration is the change in speed, change in distance over time.
Yes. So after 3 seconds, the car came here. Okay. Its speed was like 20 meters per second. Now again, after 3 seconds, the speed is still increasing. Okay. Now if you see the speed of the car, it is like double, like 40. What? Now it is 40 meters per second, meaning to say what? The car is increasing in the speed every second. Yani every second it's increasing in speed. So this is known as acceleration. Means with the passage of time, you are increasing your speed. And what is the opposite word for acceleration? If something is decreasing with time?
Accelerate.
Something going fast, slower.
Something going slower with the passage of time, and the word describe for that concept is deceleration, not deceleration, okay? Deceleration with the sa sound.
Okay.
Where is that word used? Okay, in the next lesson. So now we are going to the next lesson. Changing speed is what? Acceleration, and the formula, as Riyadh said, change in speed or final speed minus starting speed over time. Okay.
Riyadh or me, Mr.
Riyadh said this formula, the second formula. You said the first formula.
Oh, yes. Mr. You can see in the first, like in the beginning of this page, there is a picture of football players. It's two national teams, the England and the Senegal.
Okay. Now acceleration, the opposite word is deceleration. And in the acceleration, the graph is going to look somewhat like this. Okay, here you have speed, here you have time. The graph looks like this. But okay, let me write the name. Yes, here it is acceleration going on. But in the second one, it goes like this. Okay, this is speed, this is time.
Mister, your screen has stopped moving for me.
Really? Is it moving?
Yeah, now it's moving. I don't know what. Yeah.
Or not?
Yeah, now it's moving.
It's moving, okay. So this is the graph for acceleration and deceleration. Now, I want to give you a small example. A car was moving at a very fast speed. Okay, I'm using the same car again and again. This car looks like which one?
McLaren.
Lamborghini.
Lamborghini.
Lamborghini Aventador.
Lamborghini.
Lamborghini Aventador. See, he's giving the exact model name. Aventador. Okay, so let's suppose that this car was running very fast. Okay, and within the next 5 seconds, it came to rest. Here. Okay, so here the speed was 50 meters per second, which is actually very fast. Like what? Like 190 kilometers per hour, something like that. 180. Yes. 180 kilometers per hour. Okay, it's going so fast. And what happened? Since this is a supercar, within the next 5 seconds, it came to rest. Why? Because there is ishara here. Talat alf riyal mukhalfa. Okay, so it stopped here instantly. Within the next 5 seconds. Now you have to calculate the deceleration of the car.
Even though, Mr., it will be like there will be mukhalafa because of the speeding.
Yeah, Sahir.
Yeah.
Oh, I have colors. Why not use them?
In the middle, yellow.
Yes. Okay. So we are going to solve deceleration. Deceleration is what?
Going downhill with the speed.
It is final minus initial speed.
What is initial, Mr.?
Original over time. Which is what? 50 minus. No. What is the final speed at this moment? At this
Zero.
moment here, what is the final speed? 0 meter per second.
Yeah.
Because it came to rest. So
It's
it will be 0 minus 50 over what?
Over
five,
time.
five,
Over 5.
Time is what? 5
Five.
seconds.
equals to
So what will be the final answer? Minus 50 over 5, which is
Negative
what?
10. Negative 10 per second.
negative 10 meter per second.
Meter per second square. Meter
Yeah.
per second square.
Why?
Why Mr. Use square?
I will tell you.
The Mr. didn't tell us in the class.
No, he tell us, but I don't know why.
I will explain. It is very simple, but let me tell you something different. I will explain that in a moment. But wait. Now there are two ways to write your answer in deceleration. You know what? You can tell me the answer is minus 10 meter per second square acceleration, or you can tell me 10 meter per second square deceleration.
Decelerate. Yeah.
Both ways are conveying the same message.
Yes.
So that means I should have used the word acceleration here. Because if acceleration is coming in negative, meaning what? It is deceleration. Okay?
Yeah.
Are you guys understanding? For
Yeah,
example,
yeah.
you are standing on a corniche. Okay?
Yes.
This is water. Okay? This is water. And something is below 3 meters in the ocean. Now there are two ways to tell this statement. You can say the rock, okay, not the WWE rock. This is the black rock. Now you can say the rock is minus 3 meter. Okay, or you can say it is below
3
3
meters.
meter. You cannot say it is below minus 3. It will be wrong. Okay, it will
Yeah.
not make any sense. If you say below, that is also good. If you say minus, this is also good. Are you getting my point?
Mister, if we will write below negative 3 meters, it will
It
be
will be
like
positive.
plus.
It will be
Yeah,
positive.
positive.
Yes, because two negatives make a positive.
Yes.
Okay, that's why even in the following questions, they have asked that if you have like masalan minus 4 meter per second square acceleration, it is another way of saying what?
What? Oh, 4 meter per second decelerating.
Square. Where is the square?
But why we
4
have to
meter
write
per
the
second square. 4 meter per second square deceleration. Okay. Now you are asking why we have a square. Now let's go back to the formula. What was the formula of acceleration?
Final speed minus
Final
initial.
speed minus.
Okay. What was the speed? Minus 50
minus 50 over 5.
meter per second. Yes.
Yeah, meter per second.
And what was the time?
5 seconds.
5 seconds.
5 seconds. How many seconds are there in the denominator?
300 seconds.
What?
Oh, no. 5 seconds.
5 seconds square.
Oh, because 5 is.
Oh, because 1 second is coming from the meter per second and 1 second is coming from the time. Are you getting the point? There are 2 seconds now. 1 second is coming from the time or from the speed. This one coming from where?
Speed.
From here.
سرعة.
From this. Okay. One speed is coming from here and this speed second is coming from here. So there are 2 seconds in the denominator. And when two things are back to back, it is a relation of multiplication. So second multiplied by second will give us what?
5 is 2. 5 is
Listen
2.
to my question one more time. Second multiplied by second will give you what?
Second square.
Power 2.
Second square or second power 2. That's why you have a power 2 in the acceleration. Clear? Is it clear to everyone why we have a square? If it is not clear, tell me, I will re-explain. Badr, Adnan, Adam, Ibrahim.
Yes, Mister.
Is it clear that why do we have a square in acceleration but not in speed?
Yeah, in acceleration. Yeah, in acceleration you add the square, but in speed you don't add square. I understand, mister.
Okay, so let's move on. Now previously, now please student, now I'm going to tell you a mistake that students do, a silly mistake. What is the meaning of silly mistake?
خطأ غليظ.
Easy mistake or
like a mistake that could have been avoided easily, but because of the carelessness of the student, he did that mistake because of the carelessness. Okay, not because the question was tough, because of his carelessness. Okay, now what is the silly mistake? I will tell you.
To write the time on the left and distance at the bottom.
That can also be there, but now I'm addressing something else. Students do not notice that this is a distance time graph or it is a speed time graph. They think that both are same, basically same. No, there is a huge difference between distance time graph
and speed time
graph. You want me to prove it to you? Now, tell me, who is that intelligent to tell me what is the first graph showing?
Can I say?
And what is the second graph showing?
I said it, Mr. Like a while ago.
You just said 0.2 seconds before Riyadh, yes?
No, I said it. I said what.
0.2 seconds was the delay in Riyadh's response.
I know. I said what it represents, like from like 15 minutes ago, like before the break.
15 minutes ago. Wow, okay, this guy is bringing new numbers. 15 minutes ago.
No, Mr. I mean what the graphs represent. Like I told this information from before.
Okay, now you go and give it a try for this one, and then I will ask other student if they can, if your answer will be incorrect. Yes, go for it. What is the difference? From far distance, it's looking same, yani from here.
Yes.
It's looking the same thing, yes? Now let's zoom in. And here comes the problem. Yes, tell me.
Distance time graph shows like the the speed, but speed over time shows the acceleration.
You are telling me the definition. I am asking you, what do you conclude from this graph and what do you conclude from this graph? This is my question.
Like from the first graph, speed, and the second graph, acceleration.
Yeah.
Okay, next, Riyadh, give your answer. Muhammad Amir answer is not satisfactory. Same for you? Okay, khalas.
No, one second.
Now, who else? Who else wants to give it a try? What is the difference between these two graphs? Who is smart boy in today's class? Tell me.
Mister, I think you said it correct, like the speed and this, the
acceleration. Mister, I know. It's. Can I say, Mister?
No, Adam was giving some answer.
Mister, I said like, I think like Amir, like it's the speed and the acceleration.
So you are telling me that first graph is showing us the speed and second graph is showing us the acceleration. This is what Riyadh and Amir and Adam said, right?
Yeah.
But I want more.
It's written a distance time graph shows how the distance move changes with time. It's written like this in the book.
Now let me. No. It means even if I did not draw this line, blue line, you would have given me the same answer, right?
Yes.
Yeah.
Then what is the purpose of blue line? Why did I put this? There is a purpose.
Both have constant speed, Mister.
Now I caught the fish. Now the fish is stuck. The first fish is Amir. He got stuck in my trick. He's saying that both have constant speed. Okay. Where is the second fish who wants to get stuck in my net? Give it a try.
Me.
Okay, give it a try. What do you think from the first graph What do you think from the second graph? If you have a car going with a constant, yani the distance is increasing with time, it means what? It has a constant speed.
Speed, yeah.
Okay. And in this case, next,
Constant acceleration.
you have constant acceleration.
Yes.
What about speed? Is the speed same? Increasing speed.
Yeah.
Increasing speed. So you can see the difference. This guy is showing you constant speed. This guy is showing you increasing speed. So how can you differentiate? Only when you notice what is mentioned here. But if you don't notice here, if you close your eyes, you will make a big mistake. Okay, I have one more trick question for you guys. One more trick question. So let me see how many can give me the answer.
Calculus.
Now, in another scenario, I'm going to change some things. Yes. Now tell me what is happening. Now tell me what is happening.
What is this?
Turning the pages. Someone is turning the pages quickly.
In the first possible light.
What?
Both
Yes,
of them are at rest.
I think in the first one, it's at rest or it's not moving.
Very good.
And in the second one, it's moving on a steady speed.
See, this is a genius guy. This is a genius guy. Everyone, give it up for Adnan. Very good. Now look. Your time is increasing, but the distance is not increasing. Okay. Yani the time is only passing and passing and passing, but there is no movement going on. Means what? The object is at rest. Very good. Now second scenario here. What is happening? The time is passing and passing and passing, but what is constant? Speed. Speed is constant. When speed is constant with time, it means what? Steady speed or constant speed. Okay, Amir? Amir said in the starting both are at rest. No, only the first graph is at rest. Okay, is it clear?
I'm confused. What is the difference between steady speed, constant speed, and increasing speed?
Now you are going from Riyadh to Jizan. No, Jizan. You are going to Jizan. Okay. And
you're talking about the country. Oh.
And now you want to use the cruise mode in your Nissan Altima. Okay. Now, in your cruise mode, if you fix it to 100, will it go 101 and 102 and 110? Will it go like that? No. Will it go to increasing speed or steady speed?
Steady.
Steady speed. That is meaning constant speed. But what is increasing speed? You are slightly pressing the race, and slightly you are putting it down and down, so the speed is increasing of your car.
Like steady speed is the same, like steady speed and constant speed are the same.
Yes, steady speed, and I told this long time back. Steady speed and constant speed are the same thing. Where did I tell?
Where?
I think in the second. Listen.
Here.
Yeah.
I don't remember.
Like
somewhere. Okay. Yeah, here. Steady speed. Okay, I don't know. Where is it? Okay. Now steady speed and constant speed are same thing. So if you put on a cruise mode, you are going for steady speed or increasing speed? Steady speed. But when you are putting the pedal, you are pressing it, you are doing what?
Increasing
speed. When you are releasing the pedal, what are you doing?
Decreasing
speed. And decreasing speed, there is another name for that?
Decelerating.
Deceleration. Okay. Deceleration is the other name for decreasing speed. And what is the meaning of increasing speed?
Acceleration.
Acceleration. Clear?
Like Mr. The speed, no, the distance time graph can't get the steady speed, right?
It can get steady speed. What did I show here?
What
did I show here?
Oh.
It can show you steady speed, constant speed.
But if it was like it can be steady speed if the distance at time and time was moving together.
Again?
Like the distance time graph will have constant speed if both distance and time was moving together.
Yes, that means what? They are making this type of line. Yes. Then only they can move together. But if only time is moving,
yeah, if it was like
distance is not moving, means what? It is at rest.
Yeah, if it was horizontal, it will be like at rest. But if
at rest in what graph? In distance time graph.
Yes.
But a horizontal line on a speed time graph will show us what? Increasing. A horizontal line. What?
What? Oh no, horizontal. It will show steady speed. Yes.
Is everyone getting? A horizontal line on a speed time graph has a different meaning. Here. A horizontal line on a speed time graph has a different meaning, and a horizontal line here on a distance time graph has a different meaning. So please take care in the fill in the blanks.
Yeah, there's the same question, Mr. in the questions. See the second question.
Ah, yes. Now explain the difference between speed, acceleration and deceleration. I have done it so many times, so I'm not going to do it again. Now, which line is more steeper? Tell me, which line is more dangerous for a bicycle? A or B? B is more dangerous. So the speed of B will be more, definitely.
Yes.
Yes, by looking at the graph. No. But can you prove it numerically? Yani, can you just solve it and tell me actually prove it that B is more? Let's find the slope of B. How can we find the slope of B?
Make it a triangle.
Make a triangle. Now, if we make a triangle from here, it will not be good. Why? Because we cannot get this time easily. Yeah. It will be 2 point something. So instead of that, what I'm going to do, I'm going to create a graph from this point, no problem. You can even make from here. All the slope will be same. So you can make it here. You can make it here. Okay. You can make it this much big. Or you can make it like baby. You can make it like this also. This will give you the same answer. It's your choice. Yeah. Clear?
Clear.
Okay, clear. Now, from here, I'm going to take Y because it is lying even here exactly and here exactly. So it is easy for us to read these type of values. Now, let's quickly solve it. It will come somewhere here. This is the triangle we are dealing with. Now, tell me, what is the delta X, delta Y here?
Delta X is 45. 45 speed, I think. Or what?
45 what? 45 speed. What?
Meter per second.
45 meter per second. Is everyone getting?
Yeah. And
no. What is delta X?
Delta X is 2.5.
Very good. 2.5 second. So.
Mr.
Acceleration will be how much? 45 divided by 2.5. Use the calculator and tell me the answer.
45.
45 divided by 2.5. 18?
Yes.
Okay.
Yeah, 18.
18. And what will be the unit?
Meter per
second.
No.
Meter per second square.
Kilometer. Yeah, meter per second.
Kilometer, mashallah, tabarakallah. Barakallah fikum.
Mister, you remember the sound that said ساعة 8? This was from me because I have a narrator on my laptop, so he will say everything happened.
Okay, let's find the acceleration of vehicle A. How we are going to find? We are going to make a slope.
Make a triangle.
Now tell me, which of these times, which line is going in the way that we can make it easily? For the 40, it will touch somewhere here. Yani this, it is not a good point.
42.5.
30 is very good because this point can make a triangle very easily for us. This triangle. Are you getting? Badar and Adam and Adnan, are you getting how am I selecting the triangle?
Me too, Mister.
Are you understanding, Ibrahim? How am I selecting? You can make even from here. You can make the slope even from here, but that will be difficult for you. Why? Because the small divisions are not printed on this graph paper. That's why I am trying to think which method is better. And I think this blue triangle
Mister,
is
we
good.
can start from the last age, like
Because
from the
it's
letter
big,
A.
right?
So what, Adam? What happened?
Because it's big, right, Mister?
No, not because it's big, because it is passing through these lines exactly, this point. This point. That's why.
Like, Mister, can we like start the slope or start the triangle from the letter A?
From here?
No, like from the last age. Yeah, from here.
You can. So this will be given, this will get 3.5 here. This is okay. But
Yes.
what about this reading?
42.5.
And it's not that accurate. And if you have a chance, it can be 42.5. But what is better than that? What is better than that? If you start from here.
Yeah.
Why? Because it is giving you 2.5 here and exactly 30 here. Yani both places you are getting exact number.
Yes.
So you have a better chance of getting yani, most precise and accurate answer.
Yes.
Okay. Did you get my point?
Yeah.
And what other point can you use? No, here this point will not be very good because it will give you some point here. What about this point? No. This point?
10.
No. This point? No. So that is the best point. This is the best point. Now finally tell me, what is the acceleration for B?
2.5. No. 30 over 2.5.
What will be the acceleration of B?
30 meter. 30 meter over 2.5.
30 meter.
30 per second. Yeah, meter.
Over what? Over what? How much is this?
3 seconds.
What?
2.5.
Oh, 2.5.
2.5 second, which is equal to
12 meter per second square.
So which one is bigger?
No, slope A. No, slope B. Slope B.
Yes, A.
Slope of A is bigger.
Yeah.
No, Mister, it shows in the graph that B is bigger. You switch the letters.
Wait.
Yeah.
Yeah, you switch the
Mister.
letters.
Yeah, Mister, you switch A and B.
Oh. Yes. I wrote A here and B here. Sorry.
Yes.
This is B. This is A. Okay. So what we told in the starting that B has high acceleration. We just prove it even with the numbers. Okay. That B has more acceleration in comparison to A. Right?
Right.
So now you can solve graphical questions also.
Yes.
Okay. What about question number 3? It looks tricky. Use calculators and give me the answer.
I don't have the calculator here, but
You can use mobile.
I'm gonna bring the number.
Did you solve this question in the class?
Which questions?
Question number 3.
No.
No.
Okay. Now it's good. You can try it now. There are only
Mr.
5 students now. Who 2 left? Ibrahim left and Jamal left.
Mister,
Okay.
I know the answer.
What's the
Negative
answer?
100.
No, tell me the first answer. Calculate the acceleration.
Acceleration will be
Now remember the trick I told you moments back?
100 meter per second.
Yeah, 100 meter per second. Square.
Really?
Square. 100
Yes.
meter per second
So
square.
you are telling me the acceleration is 100 meter per second square.
Yeah.
Okay,
Yes.
and what is the deceleration?
Negative 100 meter per second square.
You messed up with the sign.
Mr. The answer is 100.
The answer is 100, but the issue is acceleration is the opposite of deceleration, correct?
Yeah.
In this question, what is actually happening? What is actually happening?
Decelerates.
Deceleration. So when you represent
Mr.
deceleration
the
in terms
first
of
one will be
acceleration, your
the first
answer
one.
will be minus in the first
then,
one and
plus.
positive in the second one.
Yeah,
You know
Mr.
why?
Because
Yeah,
negative
minus.
and negative is plus, and negative and
Yeah.
plus negative.
You remember now that
Yeah.
since this is a question that is dealing with deceleration, when they ask you deceleration, then your answer will be positive.
Yeah.
But when they ask you acceleration, you
Yeah,
have to
deceleration.
represent it in negative, because acceleration is the opposite of deceleration. And how are you going to solve this question in the exam? What will be the steps? You are going to show it as acceleration is equal to
Acceleration
0 minus 10 upon
No, Mr.
0.1.
10 minus 0.
Then you will get positive.
Oh, yes.
Yes. This is how you are going to show in the exam. Is it clear now?
Mister,
Yes.
Yeah.
there is something is called velocity, Mister, in the same lesson.
Yeah, terminal velocity.
Did they discuss velocity?
Terminal velocity.
Terminal velocity. Okay. Yes, correct. Now, terminal velocity is the maximum velocity a vehicle can go or an object can go. It cannot go beyond that. This is the highest possible velocity for that object. For example, if I explain you this graph, there is a vehicle moving initially. Let me divide. What is happening here? Yes. Wow, my gaming laptop is lagging because of MS Teams. No, not because of MS Teams, because of whiteboard. Okay, so I am dividing this phase into A, this phase into B, and the last phase into C. Now in the first phase, what is happening? It is very, very steep, very dangerous, right?
Yeah.
So what is happening? Large acceleration, obviously.
Like
yes.
a high speed.
Then decelerating.
Very high speed. Now what is happening? No, not decelerating. Acceleration is happening, but with at a slower rate.
Yes,
like the speed will slow down, Mister?
No. It means what? For example, you have like 0, 10, 20, 30, 40, 50, 60, 100 masalan. Now here it is going slowly up, like 101 and 102, like slowly increasing. It's not deceleration. Please students, do not get confused. It is not deceleration. It is acceleration, but at a very slow speed, like 102, then 103. And when it reaches masalan 103, now it is not increasing more than 103. So 103 is what? The terminal velocity. This is the maximum velocity for this vehicle. Clear, Adam? Clear, everyone?
Yeah, Mr.
Did you understand the 3 phases? A, B, and C. B is the most tricky for students. B is the most tricky. Adam, can you tell me the difference between acceleration decreasing and deceleration? Are these two things same or different?
Different.
Deceleration and acceleration decreasing. Are these two things same or different? And if not different, what is the difference between these two things? Please explain.
It's different because deceleration is like when something is slowing down.
Okay.
Acceleration, decreasing, it's like it takes a speed like it's moving up, but like slowly, you know?
Yes, yes, yes. It's increasing slowly, like 100.
Yeah.
Then it's going 101, then 102. But what is large acceleration? Like it's like 40 and then jumping 50, then jumping 60 and then jumping 70.
Yeah.
It is fast acceleration. Okay. I hope, Yani, this was clearly understood by the students that there is a big difference between this guy and this guy. Please do not get confused. There is a big difference. Amir, clear? Class?
Yes. Clear.
Okay. Did you understand this concept in the class? In your school?
For real.
I
no.
think the mister didn't explain.
Yeah, I think he skipped it. I think.
Yeah.
Now we are going on the last lesson quickly, and they have some graphs and then they are solving something. Presenting data from racing. Wow. Oh, this is an Indian guy, Narayan Karthikeyan. This is an Indian guy.
Yeah.
He's the champion also, yes.
I think yes. I think he's very famous in India, but like after this, I don't know any name in India. I know only one guy in Formula One, Narayan Karthikeyan, because he's like very, very famous. Okay, now what are we going to study in this exercise? We are going to, okay, now tell me, what kind of graph is this? What kind of graph is this?
Pie chart.
Pie chart. What type of graph is the next one on the right side? This one.
Bar chart.
Bar chart. What type of graph is this?
Graph.
Graph.
Which graph? Line graph. What graph? Everything is graph. But this is line graph, okay? Line graph. Line graph. Even this one.
Yeah.
This one is line graph.
Table. This is table.
Ah, this is table, mashallah. Okay, this is table. Okay, so maybe 5 minutes and inshallah we will finish. Okay, so now, this is a world champion, this guy, Sebastian Vettel. This is a world champion guy. I know his name. And even Lewis Hamilton is very famous in the world. But other guys, I don't know.
He's the last one. Miskin.
In this table, he's last, but he's like very famous, Lewis Hamilton. He did so many advertisements. Okay. Now, we can represent data in many forms. We can represent in pie chart. We can represent in bar chart. We can represent in line graph. There are many, many ways. Okay. And we can represent
continuous.
Yes, I'm going to tell you. Okay. Now, there are two types of data, discrete and continuous. Now, data is of two types. Qualitative.
Quantitative.
And what? And what?
Quantitative.
Yes. Good. Qualitative and quantitative. In quantitative, we are taking the quantities like the numbers and kilograms and meters. But in quality, we are telling it is good or bad or very fast or very slow. Yani we are telling some sifa, some quality. We are not using numbers. Okay?
Adjective.
We are using adjectives. Yes, we are using adjectives. But in quantitative, it is either discrete
or continuous.
Yes, very good. It is continuous. Now, what is the difference between discrete and continuous? This one does not need a unit.
Yeah.
Yes, it is number and no need for units.
Continuous need units and shows all types of numbers, decimals, fractions, whole numbers.
Needs units. Like what? Kilogram.
Yeah,
meter,
like 1.1
second.
kilogram.
Like this, okay? Like you are calculating speed and acceleration and mass, deceleration, mass, velocity. These are all what? Continuous data. What is discrete data? Like number of students in the class.
Yeah, like number of members in family.
Number of the pen.
Family members, yes.
Nearby.
Number of goals in a football match.
Yeah, yesterday Real Madrid won 6-0.
Oh, what?
Yes, mister.
Yes, 6-0 on validity.
Goals in match.
Yeah.
Okay, so these are all what? Riyad, did you understand what is the difference between discrete
Yeah.
and continuous? Everyone, Adnan and Badr also clear?
Yes.
Yeah, Mister, it's easy.
Yeah.
Okay. Yeah, I already understood it means a man.
Yeah.
Okay. So based on this graph, they created, I think, this line graph, because 2 is plotted with 100 and see 2 is plotted with 100 here, and then 4 with 195.
Yes.
And 4 with like something less than 200, 195. And then after creating with their hand, they join these points with the hand. Okay. And ultimately, what is the last point? 200?
300
kilometer per hour. Wow, look at the speed of this Formula One. After just 20 seconds starting the race, look at his speed. 300. But even at the 10th second, what was the speed? Look.
Yeah, faster.
Yeah.
Yani, you can just look at the graph and tell, yani, it was increasing its speed and increasing and increasing, and then the line is horizontal. Yani, the speed was constant, and then it became
Yusuf
slightly
is
less. Yusuf is faster than this, huh?
Yeah, Mr. Yusuf is the second fastest student in our school.
After whom?
Someone in grade 9 called Hussein.
Yeah.
Hussein.
Yeah, you know, Mr.
Hussein Muslim.
Yeah. Yes.
He's a nice guy.
Yes.
Okay. Drawing line graphs. Speed. Line graphs, I already told you that when the line is going up, it means what? Acceleration.
Yeah.
Always. When line is going up, it means acceleration. When line is going down, means what?
Deceleration.
Deceleration. But take care, what graph is this? If it is speed, then only our answer is correct, that this is acceleration, deceleration. But if this was distance, you cannot say that this is acceleration and deceleration. Okay?
Speed.
You have to say speed. Yes, very good. The speed, no, I mean the distance is increasing and the distance is decreasing. You are returning to the same position from where you started. So I'm not going into that. Okay. Now they are giving some notes here. What? The thing I told you. When the line slope upwards, it means acceleration. When the slope is downwards, deceleration. And when the line is flat, horizontal, constant speed. Already I told you where in the tricky question that I asked you here.
Yeah.
Here. See? Yes, Amir?
Yes.
When the line is flat or horizontal, it is steady or constant speed. Steady, I will write it in the bracket so you don't get confused. Constant.
And if it was upwards, accelerating, downwards, decelerating, for the distance time graph, if it was like horizontal, it will be at rest.
Yes.
Upwards, increasing, and downwards, decreasing.
Decreasing in distance.
Yes.
Now,
yeah, it will be
let
stationary.
me ask you a question on this graph. After 18 seconds, how much far was the vehicle?
1,200.
1,200. Very good.
Meter per second.
Now, can you tell me what?
The average speed of it?
Yes, go for the average speed. Tell me.
1,200 meter over 18 seconds. We will divide them. Yes.
Really? 1,200 over 18. Is the graph stopping here?
No, like I mean the average speed of this part between like 18.
No. It doesn't go like that. Then you can take the average from wherever. No.
When
you are finding average speed,
of slope.
You have to go till the last point. Why? Because it is not a straight line. Okay. On a straight line, you can choose wherever you like.
Yes.
But on a curved line, you have to take from the last point itself. From here.
Yeah, it will be 70 meters per second.
How? Explain the answer to me. It's not
Yeah.
1,400. This is not 1,400.
Oh, yes. It will be
1,000.
1,390.
1,390.
يعني 10 ريال ناقص.
Yes.
92.
92. See, he's giving so precise answer. 1,392 meter, yeah, mister. Huh?
Yes.
99, Mr.
Yes.
No, I will go with Badar's answer. 1,392. And what is the time taken? 20 seconds. Now use calculator and tell me the average speed.
69.6 meter per second.
You did calculator?
Yes.
Let me check. 1,392 divided by 20. Yes, 696.
Equal 69.6.
Correct. So this is the average speed. And did they find also? No, they did not find. Oh, but look at the values. Look at the real values.
Yeah. So it's 1360.
1360 divided by 20, which will give us what? 1360 divided by 20.
68.
Would have given us 68 meter per
second.
68.
Mr. Like
Yes.
if we want to calculate like the speed of the 18 part, this will be instantaneous. No. This is for the speed. No.
Now I think Amir is telling a story. Okay, so we have studied also these things that
Yes.
on a distance time graph, if it is horizontal, means what? It is at rest, stationary.
Yes.
Yeah.
Yes. Okay. If the straight line is sloping, if it is sloping, it means what?
It is
The car is moving at a steady speed. We have already done this so many times. And when the curve goes up, it means what?
Acceleration.
Acceleration.
Yeah. No,
Okay.
Mr. This is for distance.
But on a distance time graph, how do you show acceleration? By curve. By
It's
curve.
on speed, but I don't know. Like we can also.
It's not just on speed time graph. It's
Yeah.
also on distance time graph. The best way to describe it is on speed time graph, I agree. But it can be shown on distance time graph also with a curved line. Look. Where? Here. Look.
Yeah, it's distance.
Look. On a distance time graph, they are showing
They're
acceleration.
showing acceleration, yes, because it's curving upwards.
Curving upwards, yes. Okay. I think just we will discuss one or two questions and then we are done. Now, so this is the summary, and this is very, very important part. Students, please read it on your own once again, okay?
Okay.
These things are very, very important. Everyone, student, please read it yourself. This is the summary of what we did. On a distance time graph, these are the conclusions. On a speed time graph, these are the conclusions. Are you getting my point? Is my voice proper?
Yes.
Okay, please read it yourself.
But Mr. See the key points in this lesson. Variables that are names are category, numerical, discrete. Continue.
Leave it. How far did the car travel in the first 18 seconds? These questions are related to the graph that was already put up
Yes.
here. 1,200 divided by 18. Okay, the distance. How far? It's asking the distance only. It's not asking speed.
Yeah.
How far to go after 18 seconds?
1,200.
1,200 meters. Give me the answer with unit. This is a problem with OPIS.
Yeah. Meter.
After what time is the speed constant? After what time?
6 seconds, Mr.
No.
Let me start drawing a straight line from back.
I think Mr. 8 seconds. 8 seconds.
If I draw a straight line here, until where the line is straight now? You tell me. 6.
6 seconds.
So Amir's answer was correct.
Yeah.
Adam and Adnan, did you get how did I calculate this answer?
Yes.
I created a straight line backwards from the ending point. How?
How?
Like this, until all the way until here. Or you can put a ruler. In your exam, you can put a ruler.
But Master, you can also answer it by like looking at it.
Or by your finger. You can.
Yeah, by our finger. Mister, after this, the session will be ended, right?
Yes. So you can see here, until 6, the line is straight. Now before 6, it's going at a curve. That means what? After 6 seconds, the speed became constant.
Yeah, but before 6, it was what was it, Mister? Accelerating or what?
Yes, accelerating because it is curved.
Yeah.
Yes. And what is the reason? Explain your answer. You can explain that the line became straight.
Straight, yeah.
A student wants to plot the number of races that he sees and which type of graph he should make.
He should use.
He should use, okay. What is the question? The question is a student want to plot what? The number of races driver is finishing each season.
Bar chart, Mister.
For example, season 1, then season 2, season 3. I think bar chart is like good for this type of problems. Yani he can show, okay, in season 1 he took 5 races. In the next season he took 7 races. In the next he took like 4, like
4.2.
I mean, how 4.2 race he can take?
He انسحب يا مستر الماضي.
Yeah,
Like,
maybe.
Okay, so I think bar chart is enough for this one.
Yeah.
Yes.
What type of graph? What type of data is this? Discrete or continuous?
Discrete.
Discrete, because we are counting the number of seasons. We are not telling that 5 seasons per kilogram or 5 seasons per kilometer. No. Okay. So it's a discrete data. Yes, correct. So I think it's the end for today. And other questions you can go through yourself because now it's very, very late now. We exceeded 2-hour mark, but Alhamdulillah, it was like we covered almost everything. Okay, so I'll be leaving now. Assalamu alaikum. Rahmatullahi wa barakatuh. Now the sheet looks so good. Top, bottom, left, right, everything. I wrote somewhere.
Yeah.
Something or the other everywhere. Wow. I will give you the high resolution. You can just zoom in and take the details. Okay. Assalamu alaikum rahmatullahi wa barakatuh. Bye bye, brother.